February 21, 1945. Northern Sector, Iwo Jima. A Japanese machine gun crew, positioned inside a reinforced concrete pillbox, watched through their firing aperture as an American Sherman tank advanced across volcanic ash. The Type 97 anti-tank rifle beside them remained silent. Standard procedure called for letting armor approach to within 75 yards before engaging. Maximum effectiveness at minimum risk. At 120 yards, the Sherman's turret traversed toward their position. The Japanese gunners tensed, fingers tightening on triggers, preparing for the familiar crack of a 75mm cannon. Instead, they witnessed something their training manuals had never described. A stream of burning liquid erupted from what appeared to be the tank's main gun, arcing through the air with the consistency of molten tar. The napalm-thickened petroleum struck their pillbox aperture with devastating precision, flowing through the machine gun port like water seeking its level. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Inside the concrete structure, temperatures surged past 1200 degrees Fahrenheit in less than 90 seconds. The oxygen disappeared so rapidly that Corporal Yamamoto and his gun crew died from asphyxiation before the flames reached them. Those who had been positioned deeper in the complex, protected from the initial blast, attempted to flee through rear exits. Marine riflemen, positioned exactly for this purpose, cut them down as they emerged. This was not an isolated incident. Across Iwo Jima's northern plateau, on this single day in late February, 8 modified Sherman tanks equipped with flamethrowers destroyed 47 fortified positions that had resisted 3 days of naval bombardment, positions designed by Japanese military engineers to withstand direct hits from 16-inch naval guns, positions that represented the culmination of centuries of defensive military doctrine. What the Japanese defenders on Iwo Jima didn't know was that these flamethrower tanks had been created in absolute secrecy 5,000 miles away at Schofield Barracks, Hawaii, designed not by military procurement committees working through official channels, but by United States Navy Construction Battalion personnel working 20-hour days in unmarked warehouses. Seabees whose mechanical genius had transformed standard Sherman tanks into weapons that would fundamentally alter the mathematics of Pacific warfare. The Imperial Japanese Army had spent 1 full year converting Iwo Jima into the most formidable defensive position in military history. 8 square miles of volcanic rock had been transformed into an underground fortress that defied conventional military wisdom. General Tadamichi Kuribayashi, appointed to command the island's defense in June 1944, possessed a clarity of strategic vision rare among Japanese commanders. He understood with absolute precision that he could not defeat the Americans. Victory was impossible. His mission was fundamentally different. Make the capture of Iwo Jima so expensive in American blood that the United States would reconsider its planned invasion of the Japanese homeland itself. Kuribayashi had studied carefully the catastrophic failures of Japanese defensive tactics at Saipan, Peleliu, and throughout the Philippines. Traditional Japanese doctrine, meeting the enemy at the water's edge with massive banzai charges designed to drive invaders back into the sea, had proven disastrously ineffective against American industrial firepower. The general made a revolutionary decision that contradicted centuries of samurai military tradition. There would be no glorious charges toward honorable death in open combat, no warriors seeking to demonstrate their spiritual superiority through individual acts of courage. Instead, his 21,000 men would fight entirely from underground positions, turning Iwo Jima into a subterranean maze of interconnected death traps. By February 1945, Japanese engineers working under conditions of absolute secrecy had completed 11 miles of interconnected tunnels, with plans calling for 17 miles total. The finished sections descended 7 stories deep into volcanic rock. 5,000 caves and underground chambers had been carved from the island's interior, many large enough to shelter 300 to 400 men. 1,500 fortified positions crowned every strategic height. Concrete bunkers with walls 4 feet thick, reinforced with steel rods salvaged from abandoned civilian construction projects, dominated the landscape. Each position had been carefully sited by military engineers to provide interlocking fields of fire. Every inch of Iwo Jima's surface could be covered by Japanese weapons hidden behind armored steel doors that opened only to fire, then sealed shut against retaliation. The tunnel system itself represented an engineering achievement that would have impressed military architects worldwide. Ventilation shafts, disguised as natural rock formations, provided fresh air to positions 75 feet underground. Underground hospitals, equipped with operating theatres, could handle 400 wounded simultaneously. Communications centres, buried beneath Hill 382, coordinated defensive operations through miles of insulated telephone wire. Storage chambers held enough rice, water, and ammunition to sustain a 2-month siege under the most extreme conditions. The largest underground chamber, excavated beneath the hill, designated 382 on American maps, measured 50 meters in length and 20 meters in width, large enough to shelter an entire battalion with room for command facilities, ammunition storage, and emergency medical stations. This was not simply a defensive position. This was an underground city designed specifically to negate every advantage American forces had demonstrated throughout the Pacific Campaign. Kuribayashi positioned his forces according to mathematical principles that prioritized survival over glory. The southern sector around Mount Suribachi, the extinct volcano that dominated Iwo Jima's landscape, was designated a semi-independent command under Colonel Kanehiko Atsuchi. 2,000 men occupied artillery positions that could direct fire onto every square yard of the landing beaches below. The northern plateau, where terrain heavily favored defensive operations, held the bulk of Japanese strength. 15,000 men, under Kuribayashi's direct tactical control, occupied positions so thoroughly prepared that conventional military doctrine suggested they might hold indefinitely against even overwhelming force. Between these strongholds, a central reserve of 4,000 troops could move through the tunnel network to reinforce any threatened sector without ever exposing themselves to American observation or fire. American intelligence officers studying Iwo Jima from aerial reconnaissance photographs understood the island would be difficult. Reports suggested well-prepared defenses concentrated around obvious strongpoints, but the full scope of Kuribayashi's underground fortress remained invisible to cameras flying overhead. 74 consecutive days of preliminary bombing had dropped 6,800 tons of explosives onto Japanese positions. Naval bombardment from offshore battleships and cruisers had hurled 22,000 shells weighing from 5 inches to 16 inches onto every identifiable defensive structure. American military planners, confident in their overwhelming firepower superiority, projected that Iwo Jima would fall within 5 days of the initial landing. Intelligence estimates suggested Japanese combat effectiveness would be reduced by 70% through the preliminary bombardment alone. These projections would prove catastrophically optimistic. The preliminary bombardment, despite its impressive statistics, had destroyed fewer than 200 of the 1,500 fortified positions. The tunnel system remained virtually intact, its deepest chambers never even trembling from the massive explosions occurring on the surface 75 feet above. Most Japanese soldiers defending Iwo Jima hadn't suffered so much as minor injuries from the supposedly devastating American firepower demonstration. At Schofield Barracks, territory of Hawaii, 6 months before the invasion, a secret project was taking shape that would ultimately determine the battle's outcome. Colonel George F. Unmacht, a career Army officer with 44 years of military service, commanded the United States Army Chemical Warfare Service's most classified operation in the Central Pacific area. His mission, expressed in bureaucratic military language, was deceptively simple. Develop a weapon system capable of neutralizing Japanese cave and bunker complexes that had proven completely immune to conventional weapons. Colonel Unmacht's initial team was remarkably small for such an ambitious undertaking. Just the 43rd Chemical Laboratory Company, approximately 90 men with specialized knowledge of incendiary weapons and chemical warfare applications. But Wehrmacht understood immediately that the magnitude of his task required talent beyond what traditional military procurement channels could provide. He needed men who could think creatively under pressure, who possessed practical engineering skills refined through years of solving complex mechanical problems under combat conditions. He requisitioned 25 men from the 117th Naval Construction Battalion, the Seabees, whose reputation for mechanical genius and practical problem-solving had become legendary throughout the Pacific Theater. To this core group, he added personnel from the 5th Marine Tank Battalion, men who understood armor operations at the most fundamental level, and specialists from the 81st Ordnance Company who brought expertise in weapons systems integration. The result was a unique joint service team united by a single purpose that transcended traditional military rivalries: build a weapon that could burn Japanese defenders out of caves and bunkers that conventional explosives couldn't touch. Leading the technical development were two Seabees whose names would never appear in newspaper headlines, but whose mechanical innovations would directly save thousands of American lives. Machinist Mate First Class AA, Riker, and electricians, Mate Second Class, Joseph Kissel. These men brought to Schofield Barracks something military procurement offices could never requisition: decades of combined practical experience solving complex mechanical problems under the worst possible conditions. They had seen Marines die attempting to assault fortified Japanese positions that artillery couldn't destroy, that naval gunfire couldn't penetrate, that aerial bombing couldn't collapse. They understood with absolute clarity that the problem wasn't insufficient firepower. America possessed firepower in overwhelming abundance. The problem was applying that firepower effectively against an enemy who fought entirely from underground positions specifically designed to survive conventional bombardment. The challenge confronting Wehrmacht's team was genuinely daunting. Previous attempts to mount flamethrowers on armored vehicles had produced mixed results at best, complete failures more commonly. The Army's initial designs were essentially crude field modifications. Portable flamethrowers designed for infantry use, simply bolted onto tank hulls without proper integration into the vehicle's systems. The Canadian Ronson system, of which the Marines had acquired 30 units for Pacific operations, demonstrated the concept's potential but revealed critical limitations. Effective range, with thickened fuel, extended only 60 to 80 yards. Fuel capacity allowed merely 30 to 40 seconds of total firing time. The weapons were maintenance nightmares, frequently malfunctioning in combat conditions with failure rates exceeding 40% in field testing. The first American breakthrough came with M3 light tank conversions, unofficially designated Satan tanks by the crews who would operate them. The 43rd Chemical Company's initial creation, christened Hell's Afire, demonstrated that the fundamental concept was sound. Flamethrowers mounted on armored vehicles could approach Japanese positions under protection of tank armor, delivering incendiary attacks that could penetrate fortifications immune to high explosives. But the Satan tanks revealed critical weaknesses that would prove fatal in sustained combat. Turret traverse was limited to 180 degrees, exactly half what tactical doctrine required. The flame gun's elevation and depression angles were restricted by mounting brackets that hadn't been properly engineered for combat conditions. Most critically, the M3 light tank's thin armor, adequate for reconnaissance operations, made it dangerously vulnerable to Japanese 47mm anti-tank guns that were standard equipment in every defensive position. Wehrmacht's team needed something fundamentally better. Through military channels that reached directly to Admiral Chester Nimitz's Pacific Fleet Headquarters staff, they located 8 M4A3 Sherman medium tanks available for immediate conversion. These tanks, the backbone of American armored operations in both Europe and the Pacific, displaced 35 tons when fully loaded. Powered by a 500-horsepower Ford GAAV-8 engine, they could achieve road speeds exceeding 30 miles per hour, despite their substantial weight. Armor thickness ranged from 25 millimeters on less critical surfaces to 76 millimeters on the frontal glacis plate and turret face. Standard armament included a 75mm main gun capable of destroying any Japanese tank in existence, plus multiple 30-caliber machine guns for anti-personnel work. The Sherman had proven its durability through 2 years of European combat and possessed precisely the armor protection necessary to survive concentrated Japanese anti-tank fire at close range. But simply acquiring tanks was merely the beginning of UNMAC's challenge. The real innovation, the breakthrough that would transform these standard Shermans into weapons Japanese defensive doctrine had never anticipated, came when Reicher and Kissel proposed a radical approach. Instead of simply bolting existing flamethrower systems onto Sherman hulls, they would completely integrate 3 different flamethrower designs, taking the best elements from British Ronson systems, Navy Mark I flamethrowers, and captured German designs from North Africa, then combining them into something entirely new. Working 20-hour days in the oppressive Hawaiian heat, sleeping in shifts beside their welding equipment, subsisting on sandwiches and coffee brought by support staff who understood the mission's urgency, the Seabees began creating something unprecedented in military history. The resulting weapon, officially designated CBH-1, Construction Battalion Hawaii Model 1, represented a quantum leap beyond anything previously attempted in flamethrower technology. Installation of the CBH-1 system into a single Sherman tank required 150 pounds of welding rod consumed in thousands of individual welds. 1,100 separate electrical connections, each one absolutely critical to the weapon's function, had to be hand-soldered by electricians working with jeweler's precision. The conversion demanded 1,200 man-hours per tank, with 150 specialized parts machined to tolerances measured in thousandths of an inch by CB metalworkers. Each completed conversion cost between $20,000 and $25,000 in 1945 currency, equivalent to approximately $360,000 in modern purchasing power. This was not mass production. This was precision engineering, performed under combat urgency by men who understood that lives depended on their craftsmanship. The technical specifications of the CBH-1 were genuinely revolutionary. The system operated at 300 pounds per square inch pressure, triple that of previous flamethrower designs. This increased pressure translated directly into extended range, maximum effective distance, with thickened fuel extended to 150 yards, nearly 3 times the range of portable infantry flamethrowers and double that of previous tank-mounted systems. The fuel mixture itself represented months of careful development by the 43rd Chemical Laboratory, a precisely calibrated blend of diesel fuel for extended burn duration, gasoline for easy ignition, and napalm thickening agent developed specifically for military incendiary applications. This combination would burn at temperatures exceeding 1,500 degrees Fahrenheit, hot enough to melt steel and turn concrete into crumbling powder. The system's fuel capacity, 290 gallons of thickened petroleum mixture plus 10 additional gallons of unthickened fuel for initial ignition, could sustain continuous fire for up to 80 seconds, though tactical doctrine, developed through extensive testing at Schofield Barracks, recommended firing in controlled bursts of 2 to 3 seconds duration to conserve fuel and maintain accuracy. Most critically, for combat effectiveness, the flamethrower completely replaced the Sherman's 75mm main gun. This wasn't a secondary weapon or auxiliary system. The flame gun was integrated directly into the tank's existing turret mechanism, allowing full traverse of 270 degrees and elevation from -10 degrees to +35 degrees through the tank's standard fire control systems. The gunner could aim the flame weapon with exactly the same accuracy as a conventional cannon, using the identical periscope and traverse controls. This complete integration meant that tank crews required minimal additional training to operate the weapon effectively. Men who had trained for months on standard Shermans could transition to flamethrower operations within 40 hours of intensive instruction. But perhaps the most psychologically important innovation was purely visual. The Seabees, painted every converted tank in standard Marine Corps olive drab. No special markings identified their terrible purpose. No distinctive silhouette revealed their nature. To Japanese observers studying American armor through binoculars from fortified positions, these tanks appeared absolutely identical to the hundreds of ordinary Sherman tanks supporting every Marine assault. The distinction became apparent only at the moment the flamethrower opened fire. By then, for defenders trapped in concrete bunkers designed to resist artillery, it was already far too late to escape. The fuel system itself represented a marvel of practical engineering, refined under combat urgency. The main fuel tanks, positioned throughout the Sherman's interior where ammunition had previously been stored, held 290 gallons of thickened fuel mixture. An additional 10 gallons of unthickened fuel, stored separately, provided the initial ignition stream that would be set ablaze by electric igniters positioned at the flame gun's nozzle. A separate pressure tank contained compressed nitrogen rather than compressed air. This choice was deliberate and potentially life-saving. Nitrogen, an inert gas, wouldn't support combustion if the pressure tank was penetrated by enemy fire. Compressed air containing 21% oxygen could turn a damaged flamethrower tank into a catastrophic fireball. The entire fuel delivery system was designed with multiple redundant safety features to prevent the explosive failures that had plagued earlier flamethrower vehicle designs. Inside the command bunker, buried 75 feet beneath Hill 382, General Kuribayashi had positioned his defensive forces according to principles of mathematical precision. Kill zones overlapped at angles calculated to create interlocking fields of fire from multiple positions simultaneously. Artillery spotters, hidden in camouflaged spider holes throughout the northern plateau, could direct concentrated fire onto any grid coordinate within seconds of American movement. Machine gun nests were positioned to channel attacking American infantry into pre-registered artillery impact zones where Japanese gunners had already calculated precise range and deflection. The general's defensive philosophy was elegantly simple in conception, brutally effective in execution. Conserve ammunition through disciplined fire control. Remain underground where American firepower couldn't reach you. Make the Americans come to you. Then kill them with minimum expenditure of irreplaceable resources. Kuribayashi's standing orders, issued personally to every company and platoon commander throughout the Iwo Jima garrison, were explicit and unambiguous. Do not die until you have killed 10 Americans. No large-scale counterattacks would be permitted under any circumstances. Every soldier was instructed to maintain his assigned position until physically overrun, then continue fighting with grenades, bayonets, and finally, bare hands if necessary. The mathematics supporting this doctrine were straightforward and, from the Japanese perspective, encouraging. With 21,000 defenders, strict adherence to the 10-to-1 kill ratio would inflict 210,000 American casualties, far more than the entire invasion force intelligence reports suggested would assault the island. Japanese defensive doctrine had evolved significantly since the early Pacific battles, where banzai charges had resulted in catastrophic casualties for negligible tactical gain. Intelligence reports from survivors of Saipan and Peleliu campaigns emphasized repeatedly the specific vulnerability of American flamethrower operators. The weapon's signature, distinctive black smoke from burning diesel fuel mixed with gasoline, made operators extraordinarily easy to identify at ranges exceeding 300 yards. The weapon's limited effective range, rarely exceeding 40 yards in actual combat conditions, meant operators had to expose themselves to concentrated enemy fire while approaching fortified positions. Previous battle statistics documented portable flamethrower casualty rates exceeding 70%. Some specialized flamethrower units had suffered 92% casualties, making it statistically the most dangerous assignment available to American infantry. Special counter-flamethrower training had been incorporated into Japanese defensive doctrine throughout the Pacific. Machine gunners received specific instruction to concentrate fire on any soldier carrying the distinctive twin cylindrical tanks of a portable flamethrower. Snipers were allocated extra ammunition, specifically for targeting flame operators who were designated priority targets above even officers and radio operators. Infantry units practiced rapid assault tactics designed to rush flamethrower positions with bayonets, exploiting the weapon's minimum range limitation where operators couldn't depress the nozzle sufficiently to defend themselves at close quarters. These tactics, refined through bitter experience across multiple island campaigns, had proven reasonably effective against portable infantry flamethrowers. But all Japanese planning, all tactical doctrine development, all countermeasure training assumed flamethrowers would be carried by exposed infantry soldiers. The concept of armored flamethrowers, tanks capable of approaching fortified positions under complete protection of their own armor while delivering accurate incendiary attacks at unprecedented ranges, had never been seriously considered by Japanese military planners. Japanese defensive positions on Iwo Jima, carefully designed by military engineers to withstand the heaviest American artillery bombardment and most intensive aerial attack, incorporated no special provisions whatsoever against burning petroleum that could flow like water through ventilation apertures and gun ports. This single oversight in otherwise exemplary defensive planning would prove absolutely catastrophic. The fortifications that represented Japan's greatest defensive strength, concrete bunkers with walls 4 feet thick and interconnected tunnel systems descending 7 stories underground, would become death traps when confronted with weapons that turned solid defensive structures into crematoriums from which there could be no escape. The 8 M4A3 flamethrower tanks landed on Iwo Jima's beaches on February 19, 1945. D-Day, mixed indistinguishably among the regular Sherman tanks of the 4th and 5th Tank Battalions. The official Marine Corps designation was M4A3R5, though various military documents used different nomenclature, including POA CWSH-1 and CB Mark I, reflecting the confusion typical of weapons developed outside normal procurement channels. They came ashore in the 5th assault wave, around 1000 hours after the beaches had been marginally secured by preceding waves of Marine infantry. Navy operational orders specified the flamethrower tanks remain in reserve during the initial assault phases. Marine commanders, uncertain how these experimental weapons would perform under actual combat conditions, wanted to fully assess the tactical situation before committing such valuable and absolutely irreplaceable assets. The tanks were distributed with careful attention to maximizing their potential impact. 4 assigned to the 4th Marine Division operating in the eastern sector, 4 to the 5th Marine Division assaulting the western beaches. Each tank had been assigned an identification number for command and control purposes, 431 through 438. Some crews had painted unofficial nicknames on their vehicles during the voyage from Hawaii: Hellfire, Corkscrew, Blaze of Glory, but most remained unmarked, their terrible purpose hidden until the precise moment of engagement. For the first 24 hours of the Iwo Jima invasion, the flamethrower tank sat idle near the beach, carefully concealed among standard Shermans and supply dumps, while Marines died by the hundreds attempting to advance against Japanese positions that remained completely invisible until the moment they opened fire. The volcanic ash covering Iwo Jima's surface, which rose to the top of a man's calf with each exhausting step, made infantry movement physically exhausting and tactically predictable. Conventional American tactics were failing catastrophically against Kuribayashi's defensive system. Naval gunfire from offshore battleships and cruisers couldn't penetrate bunkers buried under 10 feet of solid volcanic rock, reinforced with steel and concrete. Artillery shells, even 16-inch projectiles weighing over a ton, exploded harmlessly against positions specifically designed to withstand direct hits from the heaviest guns in the American arsenal. Marine riflemen found themselves repeatedly attacking fortifications that might as well have been carved from solid mountains, positions that absorbed direct hits from multiple artillery shells without visible damage, that shrugged off naval bombardment that cratered the landscape around them, that emerged intact after aerial bombing that consumed thousands of tons of high explosive. The first day's casualties were staggering, even by Pacific War standards, where horrific losses had become routine. 2,420 Marines killed or wounded in less than 12 hours of combat. The beach itself became an extended killing field as Japanese artillery, previously hidden in carefully camouflaged positions, opened concentrated fire on the densely packed landing forces struggling through volcanic ash. Sherman tanks attempting to move inland either bogged down in ash that offered no traction for steel tracks or were systematically destroyed by concealed anti-tank guns positioned at pre-calculated firing points. By nightfall on D-Day, the invasion force had advanced less than 700 yards from the beach, falling far short of D-Day objectives that had called for capturing the first airfield and establishing defensive positions across the island's narrow southern neck. On the morning of February 20th, D+1, the tactical situation facing Marine commanders was genuinely desperate. The 21st Marine Regiment was pinned down, attempting to cross Motoyama Airfield No. 1, the southernmost of Iwo Jima's 3 airstrips. 3 massive concrete pillboxes dominated the approach, their interlocking machine gun fire creating an impassable kill zone 200 yards wide. 2 rifle companies had already been decimated in repeated frontal assaults that gained virtually no ground. The regiment had suffered 35% casualties in less than 48 hours of sustained combat. Officers were being killed at 3 times the rate of enlisted men as Japanese snipers specifically targeted anyone displaying leadership initiative. Lieutenant Colonel William Duplantis, commanding the 3rd Battalion, 21st Marines, made the decision that would fundamentally change the battle's trajectory. Recognizing that conventional tactics had failed completely, he called for the flamethrower tanks. At 14:20 hours, the 1st M4A 3R5 flamethrower tank entered combat on Iwo Jima. Tank number 431, commanded by Staff Sergeant Robert Mazer, a combat veteran of both Saipan and Tinian campaigns, approached the Japanese pillbox complex from an oblique angle, using destroyed Japanese aircraft scattered around the airfield's perimeter as cover to mask his approach. To Japanese observers watching from fortified positions, the tank appeared to be just another standard Sherman attempting the same failed frontal assault that had cost 2 Marine companies their combat effectiveness. The tank's approach was deliberately cautious. Mazer understood through combat experience that surprise would provide their only tactical advantage. Once Japanese defenders understood what they faced, they would concentrate every available weapon on the flamethrower tanks. Inside the tank's cramped fighting compartment, the 5-man crew prepared for action with the practiced efficiency of men who had trained together for months. Driver, Private First Class James Morrison, guided the 35-ton vehicle through volcanic ash that threatened constantly to bog down the tank despite its relatively low ground pressure. Assistant driver, Private Robert Chen, manned the bow-mounted 30-caliber machine gun, watching intently for Japanese infantry who might attempt close assault with magnetic mines or satchel charges. Loader, Corporal Anthony Vitelli, monitored fuel pressure gauges mounted where ammunition storage racks had previously been positioned. 300 psi indicated optimal pressure for maximum range and sustained burn. Gunner, Corporal Thomas Carlson, peered through his periscope sight, carefully tracking the nearest pillbox as the tank closed distance, calculating range and deflection for the shot that would announce their presence. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. At 125 yards from the nearest pillbox, a range carefully calculated to provide maximum psychological impact while minimizing exposure to Japanese anti-tank weapons, Mazer gave the order that would change Pacific warfare forever. Gunner, flamethrower, pillbox, fire. The CBH-1 flamethrower erupted with a sound multiple witnesses would later describe as the devil's own blowtorch amplified through a steel cathedral. A pressurized stream of napalm-thickened fuel oil arced through the air, propelled by compressed nitrogen at 300 pounds per square inch. The burning liquid, ignited by electric igniters at the moment it left the nozzle, struck the pillbox aperture with devastating accuracy. The napalm mixture splashed through the machine gun port, flowing inside the concrete structure like burning lava seeking its natural level. The effect was instantaneous and absolutely horrifying to every witness. Temperatures inside the concrete bunker soared past 1200 degrees Fahrenheit within seconds. The oxygen was consumed so rapidly by the sustained chemical combustion that Japanese soldiers died from asphyxiation before the flames physically reached them. Those few defenders who somehow survived the initial oxygen depletion attempted to flee through rear exits built into the pillbox design for exactly such emergencies. Marine riflemen who had learned through bitter experience to position themselves to cover all possible escape routes cut down fleeing Japanese soldiers as they emerged blinded and disoriented from smoke-filled exits. Sergeant Meza traversed the turret 30 degrees using the same controls that would normally aim a 75mm cannon and engage the second pillbox in the complex. This time, alerted by the destruction of their neighboring position, Japanese defenders were prepared for assault. A 47mm anti-tank gun, carefully concealed in a firing position specifically sighted to engage American armor, fired point-blank at less than 60 yards range. The armor-piercing shell struck the Sherman's frontal glacis plate, the thickest armor on the vehicle, and ricocheted skyward with a sound like a massive bell being struck. The tank shuddered from the kinetic impact, but continued advancing without pause. Carlson triggered another sustained burst, maintaining flame projection for 15 seconds, far longer than tactical doctrine recommended, but absolutely necessary to ensure complete neutralization. Black smoke billowed from every aperture of the fortification within seconds, followed by secondary explosions as stored ammunition cooked off from the intense heat. The third pillbox in the complex required different tactical approach. Its position behind a rocky outcropping prevented direct line-of-sight engagement from the tank's current location. Meza ordered Morrison to advance within 80 yards, dangerously close to Japanese infantry positions where magnetic mines and satchel charges could potentially disable even a Sherman's heavy armor. As the tank crested a small rise in the terrain, Japanese soldiers emerged from spider holes, individual fighting positions barely large enough for a single man, rushing forward with satchel charges containing 20 pounds of high explosive and magnetic anti-tank mines designed to adhere to steel armor. The tank's bowgunner, Chen, opened fire immediately with his .30 caliber machine gun, but several Japanese soldiers managed to reach the vehicle's blind spots along the sides and rear where the bowgun couldn't traverse. This was the moment when the CBH-1's modifications proved their tactical worth beyond anything demonstration tests at Schofield Barracks had predicted. Unlike standard flamethrower tanks whose flame guns could only fire in a limited forward arc, the CBH-1's complete integration into the Sherman's turret mechanism allowed Carlson to swing the turret 180 degrees and fire directly behind the tank. The attacking infantry, committed to their assault and unable to retreat across open ground, were consumed by a blazing wall of napalm that witnesses said resembled the gates of hell opening onto the mortal world. The temperature at ground zero exceeded 2,000 degrees Fahrenheit. Human bodies were incinerated so completely that identification of remains became impossible. With all three pillboxes neutralized in less than 20 minutes, Marines of the 21st Regiment advanced 400 yards in 2 hours, more progress than they had achieved in the previous 2 days of sustained frontal assault that had cost over 300 casualties. Word spread rapidly through Marine communications networks stretching across the entire invasion beachhead. The flamethrower tanks worked. More importantly, from the perspective of combat commanders desperate for any tactical advantage, they survived where conventional tanks had failed repeatedly. Within 6 hours of Tank 431's initial engagement, all 8 flamethrower tanks were committed to action across different sectors of the front lines. The tactical revolution was immediate, profound, and absolutely unprecedented in Pacific warfare. Tank number 434, supporting the 23rd Marines near the East Boat Basin, destroyed 4 separate fortified positions in a single afternoon of sustained combat operations. The crew developed an innovative technique they called corkscrew and burn, approaching fortified positions in a spiral pattern to avoid concentrated anti-tank fire while maintaining continuous suppressive flame projection. The psychological effect on Japanese defenders proved as devastating as the weapon's physical destruction. Japanese soldiers who had been trained since induction to die at their assigned posts rather than retreat began fleeing positions when they saw flame tanks approaching, abandoning fortifications they had been ordered to defend to the death. Tank number 437 pioneered breach and clear tactics while supporting the 24th Marines. The flamethrower would first neutralize a position's defenders with sustained flame projection. Then, Marine engineers would rush forward with demolition charges, permanently destroying the fortification's structural integrity to prevent reoccupation. This combined arms approach proved devastatingly effective against positions that had resisted days of conventional assault. In one extraordinary afternoon, a single flame tank engineer team destroyed 7 bunkers that had stopped an entire battalion's advance for 36 hours. But it was tank number 432 that demonstrated the weapon's true psychological impact beyond its already impressive physical destructive capability. Supporting the 26th Marines near the base of Mount Suribachi, the extinct volcano dominating Iwo Jima's southern tip, the tank approached a complex of interconnected caves. Commander Sergeant William Patterson ordered his driver to halt 100 yards from the cave entrances, far beyond the effective range of Japanese small arms or anti-tank grenades. Through the tank's periscope, Patterson could clearly observe Japanese soldiers watching from the darkness of cave mouths, calculating whether to engage or remain concealed. Patterson triggered a short demonstration burst of flame into the air between his tank and the caves, not aimed at enemy positions, simply a warning shot designed to communicate what awaited any defender who chose to resist. The psychological effect was immediate and completely unprecedented in Japanese military history. Japanese soldiers began fleeing from rear cave exits, abandoning positions they had been ordered to defend to the death, positions whose loss would compromise the entire southern defensive sector. Marine riflemen were so surprised by this mass abandonment that they initially failed to fire on the retreating enemy, simply watching in stunned disbelief as Japanese soldiers chose surrender over incineration. In 30 minutes of sustained psychological pressure, without firing a single combat shot directly at enemy positions, an entire defensive sector collapsed. This represented the first documented mass abandonment of defensive positions in Japanese military history, a culture where death was considered infinitely preferable to the dishonor of surrender. By nightfall on February 20th, Marine units across the entire invasion front were actively modifying their tactical doctrine around flamethrower tank availability. Attack plans were postponed until flame tanks could be brought forward to lead assaults. Infantry units learned through rapid battlefield adaptation to follow 50 yards behind the tanks, close enough to exploit the shock effect and suppressive capability, but far enough to avoid the heat blast that could singe eyebrows and exposed skin at 30 yards. Artillery observers began marking specific targets for flamethrower engagement rather than conventional bombardment, recognizing that some fortifications simply couldn't be neutralized by high explosives regardless of quantity expended. The tactical statistics from the first day of flame tank combat were striking even to commanders accustomed to rapid battlefield innovations. 47 fortified positions destroyed in less than 8 hours of sustained combat operations. Marine casualties in flame tank-supported sectors dropped 40%. Compared to the previous day's unsupported frontal assaults, 600 yards of territory gained in areas that had been completely static for 48 hours, despite repeated costly attacks. But perhaps the most strategically significant statistic was purely psychological. For the first time in the Pacific War, significant numbers of Japanese soldiers were abandoning prepared positions rather than dying at their posts, as doctrine demanded and training had supposedly guaranteed. The Japanese response to this unprecedented tactical development was swift but ultimately ineffective. General Kuribayashi issued emergency orders that night from his command bunker, designating the flame tanks as absolute priority targets for all anti-tank weapons. All available 47mm anti-tank guns, the standard Japanese tank destroyer weapon, were ordered to concentrate fire exclusively on flamethrower tanks. Special assault teams were hastily organized from volunteer personnel willing to attack tanks with explosive charges literally strapped to their own bodies, human-guided missiles whose only tactical purpose was destroying a single target before dying in the attempt. Infantry units throughout the defensive network received specific instruction to target the flame tank's vision blocks with concentrated rifle fire, hoping to blind the crews and render the vehicles tactically ineffective. But the fundamental tactical problem remained completely insurmountable, regardless of countermeasures attempted. The flamethrower tanks looked absolutely identical to regular Shermans until the precise moment they opened fire. Japanese gunners simply couldn't identify priority targets until far too late to effectively engage them. Worse, concentrating fire on flame tanks meant temporarily ignoring conventional Shermans that provided covering fire with their 75mm cannons and machine guns. The Americans had achieved genuine tactical surprise through mechanical innovation combined with deliberate operational security. On February 23rd, D+4, the same day that Marines raised the American flag on Mount Suribachi's summit in the photograph that would become the most iconic image of Pacific warfare, the flamethrower tanks faced their greatest challenge. The 3rd Marine Division was attempting to capture Hill 382, designated by its height in feet above sea level, the second highest point on Iwo Jima, and the absolute cornerstone of Kuribayashi's northern defenses. The hill was honeycombed with bunkers and tunnels reaching 7 stories underground, containing the garrison's command center and primary ammunition storage facilities. Japanese defenders had pre-registered every possible approach route with artillery and mortars positioned throughout the northern plateau. The position had been specifically designed by military engineers to be genuinely impregnable, featuring multiple defensive lines, interlocking fields of fire from positions that provided mutual support, and underground galleries allowing defenders to reappear behind attacking forces. Previous assaults against Hill 382 had failed catastrophically, with casualties exceeding 50% within hours of initial contact. The 1st Battalion, 9th Marines, had lost 70% of its combat strength, attempting to advance just to the hill's approaches without even reaching the primary defensive positions. At 0800 hours, 4 flamethrower tanks advanced in echelon formation, mutually supporting while presenting Japanese gunners with multiple simultaneous targets. They were accompanied by 6 conventional Shermans, providing covering fire and a full battalion of Marine infantry prepared to exploit any breakthrough. This time, forewarned by their experience from previous days, the Japanese defenders were as prepared as circumstances permitted. Hidden 75mm mountain guns, substantially larger and more powerful than the standard 47mm anti-tank weapons, had been laboriously positioned during the night specifically to engage flame tanks. These weapons, normally used for indirect fire support, had been pressed into direct fire anti-tank roles out of pure desperation. As the lead flame tank crested the first rise approaching Hill 382, concentrated fire erupted simultaneously from 3 concealed positions. Artillery doctrine called for dispersed firing positions to avoid counter-battery fire, but the tactical situation demanded massed fire on a single critical target. The first 75mm round struck Tank 433's left track, the vehicle's most vulnerable point, immobilizing it completely. The crew made an instantaneous decision that exemplified the courage typical of Marines throughout the Pacific campaign. Rather than abandon their disabled vehicle, they continued firing the flamethrower while stationary, creating a curtain of flame and smoke that obscured following vehicles and suppressed Japanese firing positions. This deliberate self-sacrifice, maintaining fire while taking repeated hits from Japanese guns, allowed the other 3 flame tanks to maneuver around the disabled vehicle and continue their advance. Tank number 431, the same vehicle that had made the first combat shot 4 days earlier, pushed through smoke so thick that navigation by periscope became nearly impossible. Artillery fire that would have instantly stopped any infantry assault rattled against the Sherman's armor like metallic hail. Shell fragments, some weighing several pounds, ricocheted off steel plating that had been specifically designed to withstand exactly this type of punishment. Driver Morrison later described navigating by periscope through smoke density where visibility extended less than 10 feet ahead, steering primarily by instinct and years of training rather than actual observation. At 60 yards from the main Japanese bunker complex, crowning Hill 382's summit, Tank 434's Flamethrower erupted in sustained fire, but Japanese military engineers, learning from their catastrophic losses during previous days, had adapted their defensive construction. Steel plates had been installed over bunker apertures. During the night, plates that could be closed between machine gun bursts to seal the interior against flame penetration. The napalm splashed harmlessly against sealed steel, flowing down exterior concrete walls rather than penetrating into the bunker's interior where it could incinerate defenders. It appeared, momentarily, that the Japanese had finally found an effective counter to the flame tanks, a defensive measure that might restore their ability to resist from fortified positions. But Gunner Corporal Michael Rodriguez, observing through his periscope sight, made a critical technical observation that would prove decisive. The steel plates glowed cherry red after sustained exposure to flame temperatures exceeding 1,500 degrees Fahrenheit. Metal, heated to such extreme temperatures, would inevitably warp, creating gaps through which flame could penetrate. Rodriguez maintained continuous fire for 45 seconds, far longer than tactical doctrine recommended and dangerously depleting the tank's finite fuel reserves. But his technical intuition proved absolutely correct. The steel plate buckled from thermal expansion, creating gaps measured in inches. The incendiary mixture poured through these openings into the bunker's interior. The confined space became an instantaneous inferno. Stored ammunition cooked off in explosive chains that blew apart interior walls. Concrete cracked from thermal shock as temperatures inside exceeded anything the original construction specifications had contemplated. Secondary explosions revealed tunnel entrances that Japanese engineers had so carefully concealed they had remained invisible through months of aerial reconnaissance. Marine infantry rushed forward with satchel charges containing 40 pounds of high explosive, throwing demolitions into every opening before defenders could reorganize resistance. In 3 hours of sustained combat that consumed thousands of gallons of flamethrower fuel and hundreds of rounds of 75mm ammunition from supporting conventional tanks, Hill 382's outer defensive perimeter had been irreparably breached. The position military engineers had confidently declared impregnable was falling to a weapon system that hadn't even existed 6 months earlier. But the Hill 382 battle also revealed the flamethrower tank's operational limitations that tactical planners had identified during testing but hoped might not prove significant in actual combat. Tank number 431 exhausted its entire fuel supply after 80 seconds of sustained continuous operation during the final assault on the summit bunker complex. Refueling required withdrawing to designated rear areas where specialized fuel trucks waited, a logistical process requiring minimum 2 hours from the moment a tank left the front lines until it returned combat-ready. During those 2 critical hours, Japanese defenders could reinforce threatened sectors and reorganize defensive positions, partially negating the tactical advantage the flame tanks had created. Most significantly, the same day as the Hill 382 assault, Corporal Herschel Woody Williams demonstrated conclusively that man-portable flamethrowers retained critical tactical relevance despite the flame tank's overwhelming firepower. When flamethrower tanks physically couldn't maneuver through a narrow volcanic ravine Marines had designated the amphitheater, Williams advanced on foot, carrying a 70-pound M2-2 portable flamethrower. In 4 hours of sustained close combat, covered only by 4 Marine riflemen, 2 of whom would die, protecting him from Japanese counterattack. Williams personally destroyed 7 pillboxes positioned in terrain completely inaccessible to any armored vehicle. Williams's technique perfectly complemented the flame tank's capabilities. Where tanks couldn't go because of terrain restrictions or tactical considerations, brave men with portable flamethrowers could still advance and engage. His actions that day would earn him the Medal of Honor, America's highest military decoration. He would eventually become the last surviving World War II Medal of Honor recipient, passing away in June 2022 at age 98, having spent his final decades ensuring that younger generations understood the true cost of the freedom they inherited. His Medal of Honor citation read in part, "Quick to volunteer his services when our tanks were maneuvering vainly to open a lane for the infantry through the network of reinforced concrete pillboxes, buried mines, and black volcanic sands. Corporal Williams daringly went forward alone to attempt the reduction of devastating machine gun fire from the unyielding positions." The statistics from the first week of sustained combat operations told a remarkable story that would fundamentally influence Marine Corps tactical doctrine for generations. In sectors where flamethrower tanks operated in direct support of infantry assaults, Marine casualties dropped by 40% compared to unsupported attacks against identical fortifications. Japanese positions that had resisted literal days of conventional assault involving artillery, naval gunfire, and aerial bombardment fell within hours once flame tanks arrived. The 8 tanks had collectively consumed 70,000 gallons of fuel mixture in 7 days of sustained combat operations, destroying an estimated 300 fortified positions. Daily fuel consumption averaged 10,000 gallons, a logistical challenge requiring establishment of special fuel depots dangerously close to front lines where Japanese artillery could potentially target them. By early March, as the battle shifted to Iwo Jima's northern plateau, the terrain itself became the primary obstacle rather than Japanese defensive positions. This hellscape of sulfur pits, twisted ravines formed by ancient volcanic activity, and sharp rock formations made tank operations nearly impossible under any circumstances. General Kuribayashi had positioned his final defensive line precisely in this sector because the terrain naturally favored defenders over attackers. The area had been grimly designated the meat grinder by Marines who had already suffered 850 casualties attempting to advance through this natural fortress. Tanks attempting to navigate the broken ground either through tracks on sharp volcanic rocks invisible beneath ash covering or bellied out on obstacles that aerial reconnaissance had completely failed to identify. The flamethrower tanks adapted once again through battlefield innovation. Unable to maneuver freely in traditional armor tactics, they became essentially mobile pillboxes, positioned at key terrain features to provide sustained fire support for infantry advances. Marine engineers from the 5th Engineer Battalion worked throughout the night, often under active sniper fire, constructing ramps and clearing paths that allowed flame tanks to reach firing positions previously thought completely inaccessible to armor. When direct line-of-sight assault proved tactically impossible, innovative tank commanders developed techniques for firing indirectly, bouncing flame streams off rock formations to reach around corners and into defiladed positions where defenders believed themselves completely safe from direct fire. These improvised tactics, developed through desperate necessity rather than formal training, would later be incorporated into official Marine Corps doctrine for urban and restricted terrain operations. On March 8, D+17, tank number 436 achieved what crews throughout the Flame Tank Battalion immediately designated the impossible shot, supporting the 9th Marines' assault on an area designated Cushman's Pocket, a complex of caves and bunkers built into a near-vertical cliff face. The tank commander, Sergeant Daniel Foster, calculated that flame fired at maximum elevation might arc over the cliff edge and fall into Japanese positions from above like burning rain. The physics were marginal at best. The CBH-1 flamethrower could elevate to 35 degrees, approaching but not quite reaching the 40-degree angle that Foster's rapid mental calculation suggested was necessary to reach the target. Foster ordered his driver to position the tank on a pile of rubble created by previous naval bombardment, deliberately tilting the entire vehicle backward to increase the flame gun's effective elevation angle. With the 35-ton tank precariously balanced on unstable ground and enemy mortar rounds falling steadily around them, creating fountains of volcanic ash and rock fragments, Gunner Corporal Anthony Vitelli triggered the flamethrower at maximum pressure. The molten napalm arced high into the air, seemed to hang impossibly at its apex for a moment, then cascaded down into the Japanese cliff positions like burning waterfalls. The effect was devastating, not merely physically, but psychologically. Japanese soldiers had believed with absolute confidence that their elevated positions were completely immune to flamethrower attack. American portable flamethrowers had maximum range of 40 yards on level ground, perhaps 30 yards uphill. Tank-mounted systems, while possessing greater range, still required direct line of sight to target. That fundamental assumption died in cascading napalm fire. Multiple witnesses reported Japanese soldiers leaping from the cliffs rather than burn alive, choosing death by falling over death by incineration, in what represented perhaps the most extreme example of the flame tank's psychological impact. By mid-March, as the battle entered its final desperate phase, the flamethrower tanks had evolved into the centerpiece of a sophisticated combined arms system that represented Marine Corps tactical innovation at its finest. Each flame tank now operated with a dedicated support team, carefully choreographed through repeated combat experience. Conventional Sherman tanks for suppressing enemy anti-tank guns before they could engage the vulnerable flame tanks. Infantry squads for close protection against suicide attackers armed with magnetic mines and satchel charges. Combat engineers for obstacle clearance and final demolition of neutralized positions. Ammunition carriers towing 300-gallon fuel trailers that extended operational time between required returns to rear area refueling points. This tactical integration represented a genuine revolution in assault doctrine that would directly influence Marine Corps combined arms operations through the Korean War, Vietnam, and into the modern era. The fuel logistics alone required extraordinary organizational effort. Electricians Mate Second-Class Kissel, one of the original CBH-1 designers, had accompanied the 8 tanks to Iwo Jima, specifically to supervise maintenance operations under combat conditions. He later reported in technical documentation that keeping just 8 tanks operationally ready required a supply chain stretching 5,000 miles back to Pearl Harbor. Fuel mixing stations operated 24 hours daily, combining diesel fuel, gasoline, and napalm powder in precise ratios that had to be maintained within narrow tolerances. The mixture had to be used within 72 hours after production, or it would separate chemically and clog the flame gun's internal mechanisms. The Japanese response continued evolving through desperate measures as conventional countermeasures proved completely ineffective. Special tank killer teams were formed from volunteers who understood their assignment was essentially suicide. These men would attack with explosive charges literally strapped to their bodies, human bombs whose only purpose was destroying a single flame tank before dying in the attempt. These tactics achieved occasional success. Tank number 438 was destroyed on March 11th when a Japanese soldier detonated himself against the vehicle's engine compartment, the Sherman's most vulnerable point, killing 3 of the 5 crew members instantly. But such tactics ultimately proved futile against American industrial capacity. For every flame tank damaged or destroyed, replacement vehicles arrived from the beach within hours. Damaged tanks were often repaired and returned to frontline service within days. General Kurabayashi, observing the tactical situation from his command bunker deep beneath the northern plateau, recognized the strategic implications with the clarity that had characterized his entire defensive planning. In his final radio transmission to Imperial General Headquarters in Tokyo, sent on March 17th, he wrote words that demonstrated remarkable professional honesty. The enemy's special flame tanks have proven more effective than all their artillery and aerial bombardment combined. They achieve in minutes what conventional weapons cannot accomplish in days. We have no effective counter to this weapon. The Americans have not just superior numbers, but superior imagination. On March 26th, 1945, Iwo Jima was declared officially secured, though isolated Japanese resistance would continue for months. The battle had lasted 36 days instead of the 5 days confidently projected by pre-invasion intelligence estimates. American casualties totaled 26,038, including 6,821 killed, numbers that genuinely shocked both the American public and military leadership, who had been assured this would be a relatively quick operation. Japanese losses were nearly total. Of approximately 21,000 defenders, only 216 survived as prisoners of war. The rest died fighting from their positions, or in increasing numbers as the battle progressed into its final desperate days, by suicide rather than face capture or death by flame weapons they had come to fear above all others. The flamethrower tanks had revolutionized the battle's tactical dynamics in ways that would be studied by military professionals worldwide. Post-action analysis, conducted by Marine Corps schools, credited the flame tanks with reducing American casualties by an estimated 5,000 men compared to projected losses if the battle had been fought with conventional weapons alone. They had destroyed over 1,000 fortified positions, consumed 360,000 gallons of fuel mixture, and fundamentally changed Marine Corps assault doctrine for attacking heavily fortified defensive positions. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.